Mastering probability can be very daunting. In this video, I'm trying to break down the basics that will empower you to choose the depths you want to learn based on your ambitions. You may know that for different analytical roles, there are some requirements for probability. For some kind of technical roles, such as machine learning or data science, you need to be very knowledgeable in probability, but for some other ones, such as business analysts, you don't need to be very deep, but you need to know the basics and concepts to be able to make good decisions and provide high quality analysis. And the data analyst roles, based on their job descriptions, they sit somewhere between these two. So it's very important to know what kind of roles are you going to follow and how much probability do you want to learn. But first, let's say why you need to know about probability to win in any kind of analytical role. Because in probability or in any kind of analytical role, you need to solve some business problems or some real world problems. And business world, real world, they are always uncertain. In a certain world, 2 plus 2 equals 4. But in an uncertain world, 2 plus 2 may be 4 and it may not be 4. So you're dealing with uncertainty and you need to know probability to be able to model that uncertainty and make good decisions and high quality analysis. For example, if your company wanted to predict their sales for the next year, you need to be able and be equipped with probability tools to be able to make good forecasts. Or if you are going to make some strategic plans for the next year, so you need to know probability or the chance of recession for the next year. So these are some examples why probability matters in any kind of analytical roles. Now it's time to talk about the basics and definitions of probability. So this part is very simple, and if you know about probability, you can skip this part. But probability, what is that? So to understanding probability, we first need to understand some terms such as sample space and event. The very normal example that you can find in any kind of textbook is rolling a die. When you roll a die, a very normal six-sided die, the outcome could be 1, 2, 3, 4, 5, or 6. This is what we call sample space. Sample space is the list of all possible outcomes in an uncertain situation. Because when you roll a die, it's uncertain, but you know the list of the possible outcomes. So here, this is something we call it sample space. Event is kind of a specific outcomes that you wanted to know or measure the probability for. For example, having 2, if you roll a die, is 1 event. And now we can easily define probability. So probability will help you to measure likelihood of an event in a uncertain sample space. For example, here probability of 2 is 1 over 6 because we have only 1 and we have 6 possible outcomes. So this is the normal or a very basic understanding of the probability itself. It's very easy, very normal, and very clear for everyone. So the next thing is that always probability is not that easy that I said, because here we could see sample space very clearly, but in the real world or in very more complicated kind of problems, it's not that easy to calculate the sample space or to know, to understand sample space. But let me give some other examples now, this time about the coin that they are somehow always found in textbooks. If you flip a coin, you have 2 outcomes. It could be tail or it could be head. So the probability of tail equals probability of being a head, as 1 over 2. But now let's say you wanna measure the probability of having 1 tail and 1 head when you flip a coin for 2 ways. So here it's very important to better understand sample space. Now let's do it together. Sample space here can be the first one is head, the second one is head. This is one outcome. the second outcome is first one is head, the second one is tail. It was the second outcome. The third outcome is that the first one is tail and the next one is head. And finally, the last one is that the both are tails. So we have now a sample space that we can understand and we can see of that. And our event is having one tail and one head. So it really doesn't matter which one goes first. Now, if you look at our sample space, there are two of them, that there is one head and also there is one tail. So to be honest, in probability, it's very important to be able to understand sample space and work with different events to understand the real probability and to measure the real probability. And the more complicated sample space will be, the more challenges you will have to measure the probability. But in a daily analytical role, it rarely happens for you to sit down and measure the probability of a kind of complicated problem. For example, the number of tails if you, flip a coin for 5 times. That's more for a school, but not a kind of analytical role. But what is really important for analytical role is more some other concepts that are based on probability. The first one is conditional probability. Conditional probability, and somehow something which is very related to that, is Bayes' rule. They are a must for any kind of analytical role. And let me give you a business example first, and then I can go for solving that. Is that maybe you did some kind of analysis that the having a revenue of 3 million for next quarter, the probability for that is 40%. Now you read an article from a very well-known institute, economic institute, that says there is a 50% chance of recession for the next year. So now you have a new data and you should update your analysis. How are you going to do that? Here, you need to know very well about conditional probability. Here, you need to measure the probability of having a revenue around 3 million if recession happens. So conditional probability is a mixture of 2 or more than 2 uncertain situations. And if you know it very well, and if you know Bayes' rule very well, you can provide very high quality analysis, some kind of analysis such as magic, and that's very valuable. Let's go more. So if you look at the formula here that says probability of A in condition of B equals probability of B in condition of A multiplied by probability of A all over probability of B. So here we know the probability of A. Let's say that having a revenue of 3 million for the next year, you already calculated that. You know the probability of B, which is the probability of recession next year, that you know from that economical institute, and now you wanna make a new guess for the probability of sales around 3 million, knowing that there is a chance of recession. Here you have all the ingredients, all the numbers except one, that is the probability of a recession when sales are around 3 million, and that could be get by historical data. You can just go and have a look on your historical data and say, in the years that you sold about 3 million, or you can extrapolate data to make assumptions. What was the probability of recession, or how often recession happened? So you can get that. So now you have all of these numbers, and you can just use this formula to update your belief. And this is very valuable for any kind of company. So conditional probability and Bayes' rule is something very important, and regardless of any kind of role you have, it's very important for you to be a master in that. The next thing that I want to talk about is random variables. That is also a must for any kind of analytical role. Random variables, they are like unpredicted characters in different stories. And you're always curious to know more about those characters to better understand the story or forecast what's going to happen in the future of that story. So random variables are somehow helpful to understand uncertainty and be able to model that kind of uncertainty, and they will give you the ability to somehow analyze any kind of decisions that were made under uncertainty. And shortly, I'm going to talk about probability distributions, and without random variables, it's not possible to understand them. And this is very important. So random variables, as you can understand from their names, they are first variables, so they can be any kind of number, and secondly, they are random. Let's go back to the die. When we roll it, the outcome could be 1, 2, 3, 4, 5, or 6. So it's always a number that is taking different numbers. So it's a variable and it's random, because if you are the best person in rolling a die, you cannot guarantee that you will always bring a 6. So this is a random variable. And for the business world, let's say you wanted to see what is the number of people who are going to buy a ticket for a particular flight in the next 10 hours. So this is a random variable, because it could be 100%, it could be 1000% based on the capacity available, or it could be any number, but you cannot say what will be that exact number. So this is a random variable. So I hope that it is clear for you. So before going on, let me give you some more examples about random variables. One of them is sum of two six-sided dice if you roll them in a row. The other one could be the stock index for tomorrow. You don't know what will be the index tomorrow, and it's all random. And even the sales, the monthly sales of your company the next month, you don't know what is the exact number. So here is some more other examples for random variables. So as soon as you know more about random variables, you can explain them and you can model uncertainty using probability distributions. So let's go back to that unpredicted character in a story. Let's say Sheldon Cooper, Dr. Sheldon Cooper in Big Bang Theory. In the first episodes of the first season, it was really hard to predict how he's going to behave in different situations. But maybe in the last season that we knew a lot of things about him, it was much easier to say that if Sheldon was here, he will act like this. So we have knowledge about that person, and we call that in real world, in probability world, a probability distribution. So probability distributions will help us to model a random variable and be able to predict how that random variable is going to behave in different situations. Here I'm going to talk about four important probability distributions that you need to know as kind of analyst, any kind of analyst, that they are very important. The first one that is very, very easy and most probably you know is normal distribution, which is always a bell-shaped curve and it is symmetric around a mean, and it is always helpful to model different kind of socio-economic phenomena, such as the age of people, the height of people, or lifespan of people in different societies. So it's very useful. The other distribution that I like to talk about here is binomial distribution. So the binomial distribution models the number of successes in a fixed number of independent Bernoulli trials. So Bernoulli trial is kind of a two outcome test that could be a success or a failure. So for example, the coin that we talked about, if you roll it, if you flip it, you may have one head, you can call it success, and you can have a tail and you can call it failure. So here the probability of success and failure are the same, but in real world, such as production management, you can have something similar, but the probabilities are very different. For example, in a production line, the probability of having a good in a high quality, I mean acceptable quality that could be go to the market is, for example, 90%. But in 10% of the times, because your goods are very sensitive, they are going to lose and be defective, so you cannot send them to the market. So here the probability of winning is 90%. So now you want to measure the probability of 5 failed products when there is a plan for producing 100 products. Here binomial distribution is going to help you to have exact number of probability. The next one that is very also interesting, and I also love it a lot, is Poisson distribution. So Poisson distribution models the number of events occurring in a fixed interval of time or space. Let's say, for example, you own a small shop and you wanna predict or model the uncertainty of people coming to your shop, for example, on Friday nights between 5 p.m. to 7 p.m. So you don't know the exact numbers, but you can use the Poisson distribution. Based on Poisson distribution, you don't know the exact number, but Poisson distribution is one of the best distributions to model that uncertainty. And lastly, the one that is very, very simple is the uniform distribution, and it's, as the name you can say, you can understand, it's uniform. The uniform distribution is characterized by a constant probability of any particular outcome within a given range. For example, for rolling a die, you will have 6 outcomes, but the probability for all of them is always 1/6. So this is a uniform distribution. I hope you enjoyed this video till here and now have a good feeling and understanding of probability, and now you can better decide to what depths you want to go and learn probability. And just to give you one final insight is, based on the kind of role, whether it's technical such as data science or it's not technical, you may be asked some kind of questions in interviews about probability. They may ask you to, for example, measure the probability of an outcome, for example, the things that we discussed here, or they may ask you some very complicated questions about a machine learning model or how to measure the probability concepts for a machine learning model. And there are some times that they will give you a business problem and they will ask about your approach, how you are going to use probability and how are you going to present that approach to a non-technical person. So this is very, very important, even more important than knowing these solid probability concepts. I hope you enjoyed the video. If so, please subscribe to the channel and push that notification button. Thank you very much. Bye bye.